Okay, can you hear me? I was told to speak loud anyway, so let me know if I'm being too loud. This is the Kafka session. I knew I'd need more seats, so I hope you can get comfortable even if you don't have one. My name is DANICA Fine. I am a developer advocate at Confluent. If you haven't heard about us, we do Kafka, we do Flink, we do general stream processing. So if you're curious about anything related to that after the talk, please come and see me. I'm happy to chat. But working for Confluent and having a rich background in Apache Kafka, I just love talking about Kafka. So I can bore you to tears on Kafka for hours and hours and hours. So again, if that interests you, see me after. But today we are just going to give you a nice, gentle introduction to all of the elements of Apache Kafka. And to keep things interesting and bright and loud, just like myself, it's going to be Lego themed because I couldn't think of anything with brighter colors. So without further ado, let's get into it. Before that, I want to make sure that we're all sufficiently motivated because I learn things much, much better when I have any bit of motivation. So, okay, why Kafka? Great question. I think there's a lot of reasons why you should care about Apache Kafka, but I think the biggest one is that real-time makes sense. Okay, right? You know, you want things now. You don't want things at the end of the week or in 6 hours. You want your data to be processed as soon as possible, as close to when it's created as possible, right? And so there has been a paradigm shift, right, in how we are dealing with our data, how we're processing our data, how we're storing our data, how we're moving our data, how we're interacting with it. And so we're moving from this whole batch-focused paradigm to stream processing, where we are pushing to process our data, again, as quickly as possible, as soon after it's created as possible. And so this whole thing is called data streaming, stream processing. And there are a lot of technologies that can help you do this. It's not just Kafka, but I think Kafka is one of the best ones. I do say so myself. I am very much biased. We can talk about that afterwards as well. But the cool thing about this real-time processing is, again, that you have the ability to treat all of your data points discretely and use them to drive your processing downstream. And more than that, Kafka is flexible. Okay, it's really flexible in how we are serving up our data. So it's not just that as that real-time data is coming in and being created, that you are processing it one by one. You could have multiple downstream systems reacting to those same events, that same data, in different ways. And again, it is really flexible. So with Kafka, if you want to just get pub sub, you can use it for that. If you want pseudo queuing, you can use that. If you want broadcast capabilities, cool, you can get that. All right, so it's pretty flexible, and you can switch that up in your downstream consumers without impacting other applications. All right, so that is the high-level elevator pitch on why you should care about Kafka, so let's get into it now. Kafka is a distributed event streaming platform. We're going to get into all those terms as we go through this talk, but before we get into those components, there's one thing that I want you to take away from this talk, and this is honestly the only thing that you have to care about, and that's events. Okay. Kafka is an event streaming platform. It's in that little tagline I gave you. So in order to use Kafka successfully, you need to understand events. You need to start thinking in events. And that might sound like a big thing, a big ask, right? Rewire your brain, think in events. But you already know how to do this. You're humans, you're users, you're programmers. Events are natural, okay? So to prove this, an event is adding something to an online cart. Right? The location of a ship, a shipping container on the sea. The act of placing a pizza order, debugging application log files, responding to a text on your phone. All of these things are events. You already know how to react to them. You just have to be more aware of that fact. So those were examples of events, but what is an event? Well, it's a thing that's happened. Big deal, yeah. It sounds really profound. It's not that big of a deal, though. An event is just a thing that has occurred. What do you need to describe something that's occurred? Well, you need to know when that thing happened. That's kind of important. When did that thing occur? And then who or what was involved, so that you can make sense of that thing that occurred. You might see this described as an event is a combination of notification and state, right? The notification, something just happened at this time, and the state that you need to describe what happened. So regardless of what your event is, a really, really important part of events is that they're meant to be immutable. And that might be a hurdle for some of you. right? We're not going to change this data once it has been created because, well, it kind of makes sense. That thing happened in the past, right? We can't go back and change that. It occurred. So you're just going to have to accept that, all right? Now, just because events are meant to be immutable and we can't change them once they've happened, does that mean that in our event-driven systems we can never undo anything? No, that would be silly, right? Going back to those examples, all events can be undone, right? We can remove an item that we added to our online cart. Just because there was an event around it doesn't mean we can't undo that. Our shipping container can go back to a previous location. I don't know why it would do that, but it could. We can call and cancel a pizza order if we accidentally placed an order for 240 pizzas and we only needed 2, right? But all of those actions of undoing an event are themselves events. Okay, so you're never deleting or changing events. You are just creating new events to describe these entities over time. Okay, and in most cases, these old events are still very much relevant for us to know. So going back to this high-level thing of events, as more and more events are generated for a given entity, describing it over time, for a specific card ID, for a specific order number, or a vessel, we're going to keep track of those events. Okay? As these events flow in, we're going to add them to a stream of immutable events that describe that entity over time, this timeline. All right, so those are events. You can walk away now if that's all you care about, because I think events are pretty important to know and understand and internalize. But for those of you who want to learn more about Kafka, let's go into it. As we go through this talk a little bit more, you're going to hear 2 words a lot: messages and records. As you're working with Kafka out in the wild, these are certainly going to come up. The data that we wish to write to Kafka should represent an event. Okay, I already said that. A thing that's occurred. To get the data into Kafka, we are going to use a producing client to send a message or a record containing that event. Okay? Not everybody is going to use events in Kafka, and if you are telling me right now you don't want to use events in Kafka, again, see me after. We can have a good chat about that. You really should be dealing with events. So more or less, events, messages, and records, you can kind of use these almost interchangeably, so I don't want anybody to get confused. Okay? So, with our idea of events settled, and knowing that we are going to be generating messages and records, now we can start to think about where we're storing these things in Kafka, because they have to go somewhere. So, the primary unit of storage in Kafka is a Kafka topic. It is typically a single data set consisting of these events. Now, an interesting thing about these topics is that our events are written in order. Okay, so if you like ordered events, cool, Kafka's got that. As you write your events into a Kafka topic, each event is going to be appended to the end. You'll also notice that each of these events, as we're adding them, each of them has a monotonically increasing number associated with it. This is called an offset. Offsets help to uniquely identify that message's position in the overall topic. And they're really, really useful for our consuming applications to know where they are in processing these events and if there's any sort of disaster recovery scenario. So far, we're adding these events to this topic. This might look and feel like a queue, right? It's not a queue. Okay? Get that out of your mind right now. A Kafka topic is not a queue. You can get queuing functionality with a Kafka topic. That's neither here nor there. This is not a queue. The data structure we're dealing with here is a log. Okay? Those are fundamentally different data structures. The biggest difference here is that as events are read from a Kafka topic, they don't go anywhere. Consuming a message from a Kafka topic doesn't mean it's popped off the end and we never see it again. All right? Kafka topics are logs. They are long-living structures that store these events for some configurable amount of time or a space requirement. And while that data is in that Kafka topic, any number of downstream applications can make use of it in different ways. All right. Keep adding them. Another thing to keep in mind is that these topics are also immutable. There's a lot of immutable things in Kafka. Just deal with it, okay? Once the data is written to this Kafka topic and it's been given an offset, it's there. We're not going to go and remove it. That thing occurred. We've written it to the topic. It's there. So if event number 3 is our erroneous pizza order, mistakenly ordering 240 pizzas that we didn't mean to do, that's unfortunate because we have also done other things since then, right? Now, what if I want to go and change that pizza order? Okay, and we're going to generate a new event to update it, reduce it down to 2 pizzas. Well, cool. Then I'm going to add a new event to the end of that. Okay, we're not going to go and delete event number 3. We are instead going to add a new one to update that entity, that particular pizza order in this case. All right. So, to summarize, primary unit of storage in Kafka is the Kafka topic. It is a durable, immutable, append-only log, not a queue, log of events that we can continue to add these events to for as long as we wish, and they're going to be stored there for as long as we configure them to be stored there. All right. But we don't actually stop there. Topics are broken down into smaller components called partitions. Here we have a Kafka topic that we configured to have 3 partitions. Now, typically, how you split your data up across the topic partitions is based on the key of that data. So in this case, you can take take a hash of the key and then determine which partition it goes to. In this case, maybe it's the color of the brick of the event. This isn't always the case, though. There's different partitioning strategies that you can employ. Yeah, you can even implement your own if you want to. So everything that you learned about topics effectively applies at the partition level. So new data is going to be appended to the end of the partition. And you'll also see that the offsets will repeat across the partitions, right? So each record is going to be assigned an offset that is that it uniquely identifies its position within that partition, okay? So what this means is that based on these offsets, the events are only guaranteed to be ordered within that partition. All right, so if you need ordering of your events for a particular entity, be sure to key by that so that you can ensure that your data is going to be properly ordered within that topic partition. Right? And each of these partitions are backed by a durable log, and any size-based retention limits are going to apply at that partition level. All right. More motivation. Why partitions? Why should we care? Because the reality of it is that you could be a user of Kafka and not really think that much about partitions and the nitty-gritty and why we're doing it. You can just put data in, get data out, and move on with your life. But I think it's good to understand. So first and foremost, Kafka is a distributed system. So partitions are going to be how we distribute our data across our Kafka cluster, and ultimately how our downstream applications are going to scale. So generally speaking, the more partitions you have, the more that you could potentially horizontally scale out your consuming applications. But you don't want to go too far. Too much of a good thing is an awful thing, or could be an awful thing. And there's entire talks and blogs out there on how to choose the right number of partitions for your particular use case. But the resources are there to help you choose. I'm not just going to say, deal with it and figure it out. But I'm not going to go into the gory details here. But know that choosing the number of partitions is an important thing for how your applications are going to evolve over time. So we are partitioning. It makes sense. How do we distribute them across the cluster? Great question. So the nodes of a Kafka cluster are called brokers. And these brokers can be running, use your imagination, wherever you want. VMs in the cloud, containers, bare metal, it doesn't really matter. Spin up your brokers. And so here is a simple Kafka cluster with 3 brokers. We have 3 topics represented here, each with some number of partitions. Now, results may vary, but this is one potential outcome for how these partitions are distributed across the cluster. But the goal of the brokers in determining where these partitions live is that they want to evenly distribute these partitions as much as possible across the cluster. Okay? Why bother? Why put the partitions on different nodes? Well, the biggest reason is when it comes to processing that data later on. As I mentioned before, having these partitions is going to control how we can scale our downstream applications and potentially parallelize our processing later on. So you'll want your data to be spread as evenly across the cluster as possible. Okay, so this is good. Seems pretty nice. I like it. Cool. Well, something's going to happen. One day, the intern's going to trip, and we're going to take down an entire data center, and all right, we're going to lose a broker. This is not ideal. How are we going to handle it? Well, the good news is we only lost 1/3 of our data, right? Yeah, of course, the bad news is we lost 1/3 of our data. That's very much unfortunate. We could maybe continue operating if all we cared about was, partition 0 and 2 of topic B. That's fine. But Kafka knows that this is not good enough. We're going to take it a step further with something called replication. So this is a configurable parameter that determines how many copies of a partition is going to exist across the cluster. So with replication in mind, we're going to look at a 3-node cluster from the perspective of one topic with 3 partitions. Okay? And this time we're going to use a replication factor of 3. So you'll see that we have, for each partition, we have 1 leader replica, that's the dark blue, and we have 2 extra follower replicas for each partition. So what happens when we have replication enabled is that when we are, say I'm a producer, I'm writing data to partition 0 on broker 0, right? We are first going to connect to the broker that owns the lead partition, the lead replica for that partition, okay? And then synchronously, we are going to replicate that data over to the other brokers across the cluster where our follower replicas exist, in this case on brokers 1 and 2. A really important thing to notice is that the followers don't live on the same node as the leader. Okay, that's by design. We don't want our backups to exist on the same machine because now, when our brokers go down, okay, that again, unfortunate. But as soon as the cluster is aware that this broker is gone, we are going to look at where we have copies for those leader partitions, and we're going to say, okay, there's one on broker 1. We are going to promote that one to be the new leader because it is an up-to-date copy. And so now our producers can continue producing to that broker 1, and our consumers can continue consuming, right? That was a bit of an aside, but I think it's worthwhile understanding some of these details, just to showcase how, Kafka is pretty good at storing your data, right? In a reliable and persistent way. Okay. So now we know how data is stored in Kafka. It's time we understand what these records actually look like. So it depends, like many computer science questions. It depends, but there's a few pieces of information that you definitely need when you're writing data into Kafka and some optional fields. So all you really need to know is what topic you are writing to and the event that you're writing, the value of that message. As for optional fields, there are many. So you could optionally include a specific partition that you want that message to go to. Okay? If you leave that out, your producer is going to use whatever default partitioning strategy it is aware of and use that to compute the partition for you. You could include a timestamp. Now, if you don't include a timestamp, your producer is going to use the current system time, okay, to send along with your message. You could include a key. If you care about ordering, you should probably use keys and understand how that's going to play into how your data is partitioned if you're not already choosing a partition for yourself. And also you can include some headers. Okay, so as an example, let's say I am shopping on Lego.com. I do not work for Lego, full disclosure. I'm a fan. I'm shopping on Lego.com. I'm using their Pick a Brick feature, and I've just added a blue 1x1 plate to my cart. What does this record look like? Well, I'd likely be writing to some topic containing other updates, adding things to my cart, removing things to my cart. So let's call it the cart updates topic. Ooh, creative naming. All right, so we are dealing with events, right? So what would be the event that describes what just happened? Well, I added a blue 1x1 plate to my cart. It probably has some ID, so very creatively, it is cart ID 1234. Cool. So that is the event that we're going to use to describe this, add it to the value. As for optional fields, I'm going to let the producer do what it does best. We are not going to override the partition. I'm not going to override the timestamp, so we're going to use the current time now. And as for keying, I'm trying to envision, what sort of use cases I would want to do with these cart updates data, and maybe I want to understand and start to predict what users need based on what they're doing with their carts, right? So it would probably be worthwhile to key by the cart ID so that we can understand what individual users are doing over time. So I'm going to choose the key to be cart1234. Headers, I'm not going to add any. So now we can take that record, give it to our producer, and producers are great. They can be written in pretty much whatever language you want. There's a lot of clients out there. And we're going to take this information, we're going to write it into Kafka. Not really. Okay, there's more. There's more to be done. Brokers speak in bytes. They don't care about your nicely formatted object. They don't care that it's human readable. They don't care. They want their raw bytes. And so what this means is that we need a serializer. Okay. Commonly supported formats in Kafka are Avro, JSON, Protobuf. We're working on Parquet as well. So all you need to do is you need to configure your producing client with the right serializer for your object, and you'll use the corresponding deserializer on the consuming end to get the data out. And what this means, ultimately, is that you should use a schema, right? And I'm going to pretend that every one of you nodded like, yeah, schemas, they're so good. Yeah, of course I'm going to use a schema. I'm just going to pretend that everyone uses them all the time and spends time up front for this. So yeah, here's a pretty basic Avro schema that describes these events that we're just talking about. So we have our cart ID, the particular action that we're dealing with, whether we're adding something or removing or updating a cart, the particular element ID for the pick a brick feature, the unique Lego element, its description, and the quantity. Okay. And you might be thinking to yourself, all you schema naysayers, that it's one thing to know what your data should look like, and another thing entirely to enforce it, and you're right. We'll get to that later on. But for now, let's get that record into Kafka. So here, I've taken that event and parsed it out based on that schema that we just created. I have the key called out as well. And so I can configure this producing client with the correct serializer for this particular schema, and we can write that cart update event into our cart updates topic. But first, I want to tell you a little bit more about what producers do. All right, they are not just, you call producer.send and that data is shipped off to Kafka in this magical little black box of a pipeline. But producers are actually doing quite a bit for you under the hood. So the first thing they're doing is they are looking at that serializer, if that exists, and serializing that object into bytes to be shipped off to the broker. Then, if you didn't override it, it's going to compute the partition where this data is going to go. Using the key or lack thereof, it's going to decide how to dole this data out to the appropriate brokers that own the partitions for that topic. Then, to be a little more efficient, that producer could be configured to batch your data a little bit, just a little bit. Okay, so that we can take advantage of that round trip time that we're spending to send that data off to the producer or to the broker. It's going to try to group data that is going to the same broker to the same topic partition together, just to be a little more efficient. Optionally, they can compress that chunk of data as well. And then finally, they're going to make that request for you. Okay, so there's a lot that goes on the producer. Thank them next time you see one. All right. And now that record is going to be beautifully appended to the end of that cart updates topic. Great. Now, storing data in Kafka is only half of it, right? It gets a lot more interesting when we read the data back out and do things with it. So let's add consumers. Woo. So how do they work? Okay, so we saw how the producer gets the data in. What are the producers actually doing? Well, they're getting data out. So we have our cart updates topic with our events in it that our producer has been writing to. Now we have a consumer, some sort of application that wants to read from this cart updates topic, again, to maybe make sense of user patterns with their carts over time. It doesn't really matter what the business logic is. I don't really care what the business logic is, but the consumer wants to read that data. When the consumer is first started up, we have options. Where should it start reading from on this topic? There are two main options. The consumer can either read from the most recent event that was written to the topic, or the earliest event, the Kafka topic. Those are your choices, okay? I want this consumer to have as much of the information as possible, so we're gonna start it from the beginning of the topic. So what are we doing? Well, the first event that the consumer reads is going to be the event with offset 1, right? That makes sense, first one. It's going to do its thing, whatever business logic it is, in some hand-wavy way, it doesn't matter, it can do it. And then it's gonna process the next record and do whatever business logic it has. Cool. So every so often, our consumer is going to do a little bit of bookkeeping, right? And it's going to record the offset of the event that it has fully processed, okay, that it has most recently seen and processed. So we've processed event 1, we've processed event 2, cool, we are done, we're about to read event number 3, but the consumer is going to connect to the brokers and it is going to say, hey, for this Kafka topic, for me, I have seen up to offset 2. Remember that. right? So it is going to periodically commit this data back to the brokers so that we can keep track of this. Okay, so cool. While the consumer is doing what it's doing, producer can do what it's doing, okay, and keep producing the data. Producers and consumers don't care about one another. They will never care about each other, okay? Completely decoupled. Producers can do its thing, multiple events. It doesn't matter if the consumer has, pretty heavy business logic to implement. Doesn't matter how long it takes. So the consumer, again, can keep doing its thing, updating its offset at the same time. But, it would really be unfortunate if our consumer died, yeah? But that's going to happen. It's an inevitability that our downstream applications aren't always going to be online. But cool, well, the producer can keep doing its thing. It doesn't care, right? It's going to keep producing to that topic, regardless of whether or not there's applications to actually consume that data. But eventually, hopefully, that consumer is going to come back online. And when it connects, it's going to ask the brokers, all right, what's the last offset I saw? And it's going to be given offset 3. And so it knows that it can keep processing from offset 4 now. Okay? And cool. Then we can go on our merry way. Awesome. So in this way, with those consumers and producers decoupled, we can add as many consumers as we want to consume from this Kafka topic and do different things with it. Okay, they're not going to affect one another. They can each process at whatever, with whatever requirements and time that they need to implement their business logic. And they're all going to independently keep track of their offsets for their particular consuming application. Right? Now, there's more. So we talked about producers and consumers being completely decoupled and not caring about one another. And those consumers can be completely decoupled from one another, right? They're not going to affect each other. But what if we wanted them to be coupled? Wouldn't that be fun? So we can parallelize the processing, right? Because right now, if we just have one consumer consuming from this 3-partition topic, well, that consumer is going to be processing the data from all 3 partitions, right? And that might be fine in the beginning, depending on how much data we have going through this topic. But maybe we might want to add another application, another consumer, to do the same thing. It implements the same business logic, but we want to be able to parallelize this processing. All right? So by doing this, we are forming something called a consumer group. Okay? So a consumer group, the way that you can configure them is you just spin up multiple instances of that consumer. You configure them to have the same consumer group ID, which is literally just a string you assign to that consumer. And the brokers are going to see these consumers come online with that same consumer group ID, and they're going to dole out partitions amongst the consumers in that group, right? So when you're a part of a consumer group, each partition is only going to be consumed from by one consumer in that consumer group, okay? With the goal of parallelizing this processing. So we could keep going in this way. We can add a 3rd consumer, and this is great, right? We have 3 partitions, we've got 3 consumers, so we've reached peak parallelism, right? We are consuming data in parallel for each of these 3 partitions, and that's wonderful. That's what we wanted. Now, we don't have to stop there. We could add a 4th consumer, and you can add a 5th, 6th, 7th, it doesn't really matter. And I've actually seen this as a strategy for redundancy, is having extra consumers in there just in case one of these other consumers die. All right. So consumer 4 over here, we call it a starved consumer. It has no partitions that are being assigned to it because there are no other partitions to give to it. Right. It is being very opportunistic. It is simply waiting for one of these consumers to go down. In which case, we will rebalance and assign that partition from that consumer to this 4th one. And note that as all of this is happening, we are still committing these offsets back to the Kafka brokers based on the topic partition. Okay? So in the case that we do need to switch over which consumer is consuming which partition, when they start up, they're not going to start from scratch. They're going to know which offset they left off at for that partition assignment. Okay, that was a lot of information. Let's take a break. At this point, you should understand sort of the basics of Kafka, at least from the consuming and producing side of things. So it is a distributed event streaming platform. We use producers to write events as records and messages into Kafka topics, where they are stored in specific partitions across specific nodes in the cluster. For added reassurance, we are replicating that data to other nodes across the cluster. And at any given time, consuming applications can come along and read from the data from any number of topics and use that data for completely different use cases. And remember that these consumers can work together as part of a consumer group to parallelize the processing of this data, and that parallelism is capped at the number of partitions. Okay? So in a nutshell, that is Kafka. Vanilla Kafka. And I feel like saying something is vanilla is kind of like a negative connotation. It's boring. So I want you to get that out of your head, right? With just plain Kafka, there's a lot that you can do with just that producer and consuming model. You can build out a data mesh. You can implement a full microservices architecture for your real-time data, and that's pretty powerful to just do with producers and consumers. But if we take that power of just Kafka and sprinkle on a little bit more, let's take a look at that. Let's look at the broader Kafka ecosystem and see what else we can do to make our use cases just a little more sophisticated. So let's go back to an example from earlier for all you schema naysayers. Right, we're coming back to it. So we have our producer taking an object that it follows some schema, right? And we want to write that to our Kafka topic. Well, we know that brokers only speak in bytes, so we are going to serialize that object before we then store it in our Kafka topic. But what happens when our consumer comes along and it wants to read those bytes? How does the consumer know what that object's supposed to look like? Now, if we're lucky, that consumer also has a copy of that same schema and can use that to set up a deserializer and get that original object back. But one of the great things about Kafka is that the producers and consumers are decoupled. Right? And if I'm implementing the producer and I decide this is a schema for that data, and maybe, I don't know, maybe it's another team entirely that's building out the consumer. If they need to know about this schema, then I have to manually hand them that schema, right? And I don't know, I don't want to be the single point of failure. I would like to not. All right, so I think we can do better. And Schema Registry is here to help us do better. So there's a couple different implementations of Schema Registry out there, but generally they follow the same constructs. Schema Registry lives outside of your Kafka instance and helps you to keep track of your schemas and related metadata. It allows for different schema compatibility levels, so you can keep track of how to upgrade them from different your producing and consuming applications. And the real great thing about Schema Registry is that it helps us to maintain that decoupling between these applications in a programmatic way, so that we don't have to manually step in and upgrade schemas and deal with that. So great, it holds our data, holds our schemas, it enforces quality, but how does it actually work? So producers are going to maintain a local cache of schemas that they, for the data that they're writing, for the topics that they're writing to. If when we see a new schema that's not in their local cache, they're going to go to Schema Registry, and they're going to add that schema, register it with Schema Registry, and in turn, they're going to be given an ID associated with that new schema. So only once that schema is registered for that particular subject, that topic, can the producer actually write that data to the Kafka topic with that schema. All right? So when they write the serialized bytes, those raw bytes are going to be prepended with a schema ID and a magic byte that helps to say that this data adheres to a schema, and we should be aware of that. Now, on the consumer side of things, when they go to read the data, all right, they are going to see that magic byte. They are Schema Registry enabled. They know that they should be looking at Schema Registry for schemas. They're going to see that magic byte, extract the schema ID at the beginning of that series of bytes, and it's going to use that to either look up that schema in its local cache or access it from Schema Registry. Okay? So in that way, then they can deserialize the object as expected. So this is just a programmatic way. It might sound like, hey, middleman to the rescue. But this is great because now it can happen in a programmatic way, and I don't have to stand in there and move schemas around. Okay. So now we can ensure the quality and format of our data. Things can get even more interesting, right? We can do serious things with Kafka. So the next thing you might want to do is, as your applications evolve and mature, is you might want to connect Kafka with other systems. So very, very rarely do people get the opportunity to start from scratch and just implement Kafka and deal with Kafka. So Kafka Connect is here to help you integrate with other systems that are inevitably going to exist in your architecture. Okay, so Kafka Connect is a way to connect Kafka with external data sources and sinks. And when you run Kafka Connect, it is a framework. You point to your data sources, and you can periodically and programmatically pull the data and translate it into events and write it to Kafka topics. On the other side of things, you can move your events from a Kafka topic out into some data sink. Okay. So the cool thing about Kafka Connect is, again, it's a framework for moving data in this way. So it provides a way for you to define your connectors and the data pulling and the writing tasks. And then anyone else can implement and instantiate a particular connector for their particular database. All right. So don't worry, you don't need to implement your own. There's hundreds of connectors out there that exist for you to just provide a configuration for and start running. So once you decide which connector, which data source and sink you want to be connecting to, again, you're just providing a configuration. How do I connect to that data source, that data sink? If it's a JDBC connector, which tables am I pulling from to eventify and put into Kafka, or which query am I executing against these tables to bring them into Kafka? And how does Connect do this? Well, it's just built on the consumers and producers that we just talked about, right? All of it's built on top of that. Kafka source connectors are going to read data from your databases, and they're going to use a producer to write that data into your Kafka topics. On the sink side of things, we're going to use consumers to consume data from the Kafka topics and write it out into your sinks. So we've seen how to keep track of our data, enforce quality, how to integrate with external systems. The next critical thing you might want to do with Kafka is process your data in an interesting way. So this can be done in Kafka itself, but there's also other technologies outside of the ecosystem that we'll touch on. So first of all, how do we do this within Kafka? Many options. The first way you might want to process your data is just with the consumer and producer API that we've already talked about, right? So this is great because the consumer and producer APIs, they're available in a lot of languages, right? And pick one and you can run with it. But for stream processing, it can get kind of interesting. Think about it. So if you want to do some stream processing with producers and consumers, well, you need to set up a consumer to read your data from a Kafka topic. You implement your business logic in there, right? And then you set up a producer to produce back to Kafka. For stateless processing, cool, you're good, right? You spawn up an instantiated instance, whatever, you start running, great. When you add state to it, though, things get complicated, right? Especially if you want to parallelize your processing and you're spinning up multiple instances of a particular application. Now you need to think about, how are we making it fault tolerant? What happens when one instance goes down for some reason? Where are we storing that state? Is it on the local machine? Well, what if the machine goes down, right? So there's a lot more to think about. And you can do this. You can set up producers and consumers to do stateful stream processing and be completely fine. It just comes down to what your requirements are. So if you are sane, you're probably going to use one of the next ones. So moving up in ease of use is Kafka Streams. Kafka Streams is a Java and Scala library purpose-built for stateful stream processing. What it does really, really well is it takes this hassle of managing state off of your hands. So to use Kafka Streams, you effectively define a topology of how you want your data to be processed for that particular use case. Right, so you set up processors to filter, to map, to join your data, and then you define which input topics are flowing in and where what sync topics we are writing to. Okay, and then from there, you can spawn up an instance, right? And I don't know, if we have 4 partitions in that input topic, we can bring up 4, 5, 6 running instances of this Kafka Streams application. And it's built on top of the consumer and producer API, so we can take advantage of that consumer group protocol and parallelize the processing of those input partitions for the topology. But it's still, again, built on the consumer group protocol. So we are going to commit our offsets back to Kafka so that we are aware of when things fail over, how do we start up again. And we're also going to commit the state back to Kafka. So in the middle of your topology, as you're processing each event, we are going to write the state update for that stateful application back up to Kafka in a Kafka topic. And so again, when we have any sort of failover scenario, that state's going to be written to the local machine just in case that partition is reassigned to that particular instance when it comes back online. But if it doesn't, then wherever that partition is reassigned to, it is going to, that instance can be made aware of the state from reading it from the Kafka topic, right? So you never have to worry about that failover. We are going to have that state available for you. And finally, the easiest way to do processing with Kafka is with KSQLDB. So this is a SQL wrapper on top of Kafka Streams, just in case you don't want to go through the whole process of writing the Kafka Streams application. It just makes it a little bit easier for folks to use. And so that was just on the Kafka side of things. There are so many other stream processing technologies and frameworks out there for you to make use of if you want to read your data from Kafka, process it, and write it back to Kafka. So this is just a handful of some of the technologies that play well with Kafka. They have ways to connect to Kafka, read that data out, and again, do your processing and write it back to Kafka if you want. I don't really use all of these at any given time. I've played around with a couple of them, so I can't speak to much of the specifics, but it doesn't really matter which one you pick, which kind of sounds like it's a weird thing for me to say. But the cool thing about Kafka is that any number of downstream applications can consume this data and make use of it, right? So you are free to look at all of these stream processing technologies and frameworks, play around with it, build out POCs, make use of different ones for different applications and use cases, and really find out what works for you. Okay, so I encourage you to play around with them, assess which stream processing frameworks work well for you. But that's the beauty of it. All right, so let's take a quick survey now of some of the cool things that you can do with Kafka, right? I've given you all the pieces in the ecosystem and the elements of Kafka, so let's shop around in the Lego store and see what else we can do with it. All right, so first up, financial services. You want to build this set, I know you do. So I think one of the most compelling use cases for using Kafka is in financial services. I've seen a lot of really interesting use cases in banks and other financial institutions where Kafka is at the core of their real-time market data and how they process that out for markets. IoT and manufacturing is another big use case, and especially an up-and-coming one with Kafka. So if you are not familiar with manufacturing, so in a lot of cases, a factory is built up, there's multiple manufacturing lines in there, and there's dozens, hundreds, thousands of sensors at each stage in that processing line, right? And usually that information that's being collected from those sensors stays within the factory, okay? That's fine, but for larger institutions that have multiple factories globally, it would make sense and probably be more efficient and more useful if we could get that data out of those factories and maybe update our supply chain in a little more real-time way, provide more granular insights into what's actually happening globally on each of these manufacturing lines. So this is a common use case we're seeing, is just increasing the visibility and transparency from these individual lines for a global system. And generally, inventory systems, right? When an entire catalog of inventory for a given business could be kept up to date at all times, and having all of this information written into Kafka and maintained in Kafka. And this could just be one small component of a larger microservices architecture where we are maintaining all of the orders that are coming through for an e-commerce company, where our shipments, our user information, our inventory updates are all kept and maintained in Kafka. And I could keep going on and on about what the cool things you can do with Kafka. If you are interested in seeing more, because why wouldn't you be interested in seeing more about Kafka? Here is a QR code to my link tree. On it, I post interesting resources, interesting things that I'm working on, use cases. So I encourage you to check it out. The biggest link on there that you should be aware of is a link to Confluent Developer. So that is our developer portal with a ton of resources with demos, tutorials, and we have dozens of free courses for you to take advantage of, spanning from 101 courses covering and reinforcing some of the stuff that you learned today to more intermediate and advanced ones like diving into the internals of Kafka and working with Schema registry and building out a microservices architecture as well. So I encourage you to check it out. It's a great place to, again, solidify what you just learned today and see what else is out there. And another cool thing is that DevOps this year has a lot of Kafka talks. Okay, so I was the first one in the lineup, but there's one this afternoon with Kate Stanley. So I encourage you to check it out if you want to learn more about Kafka Connect. It's going to be a great session for you. And there's a couple other interesting sessions on Friday as well if you want to dive into some more interesting use cases. So please don't let this be the last time you think about Kafka. I hope it is the first and is the beginning of a beautiful friendship with Kafka. So that is all that I had, and I think I have a couple minutes for questions. Thanks.
First of all, let me say it was a great talk. I'm wondering, how does Kafka handle the exactly once semantic? Is it some kind of at least once plus some voodoo magic on the producer side of things, or does it support it all?
Yes, exactly once
semantics. And how
semantics.
does it do it? There?
Man, that's a whole talk. Do you guys got an hour? Yeah, I've got time. So yeah, for exactly once semantics, that is literally just a configuration that you can add for your Kafka Streams applications. So if you want to ensure, like it sounds, that each event that flows through that topology is going to be processed exactly once and exactly one output is going to produce, that is an easy thing that we added on to Kafka Streams to make that happen. As far as getting your data into Kafka and maintaining it, making sure that that data is just produced to Kafka once. There's a couple other configurations that you have to employ. So we have an idempotent producer. That is the default functionality for producers in Kafka as of many versions ago. You could quote me on that because it's not technically untrue, but I can get you the actual number. So we have the idempotent producer, and so with that, within the lifetime of a particular producer, we can ensure that an event is written and stored once. Across producer sessions, if that producer goes down, there's some hand waving in there, and data could be duplicated, but you can get around that for intensive use cases and applications by using transactions on your producer. So there's a lot of ways. Once the data is in Kafka and you're processing, we have EOS in Kafka Streams. On the producer side of things, there's idempotent producer or transactional producer to make sure that your data is written once. Yep. And then there's whole talks if you just Google it on the specifics. We have a question here. Oh, he's got the mic.
Sorry, a very nice talk. There was a slide about the partitions and in the topic. I was just wondering about skewed partitions where a partition is overloaded with data and some partitions don't. So how does it play with Kafka?
Yeah, that sucks. Just going to say that. Hot partitions really are awful. So that's why it helps to understand what your data looks like, what the distribution of your data you anticipate it looking like later on. So I used to work in financial services with market data and Kafka. And so heavily traded securities. We're going to have more information for that, and that's going to be a hot partition for that particular key. Unfortunately, you can't really add partitions to a Kafka topic. You can't really remove partitions from a Kafka topic without a specific sort of migration and downtime, over the weekend when markets are closed, right? And migrate over to sort of alleviate those hot partitions. What we did is we did a long-term assessment of 6 months of market data or 6 months of whatever data you're dealing with, and see how with the default partitioning strategy how that data is being distributed, and then we manually rebalanced things and wrote our own partitioning strategy to help get around that. So again, it helps to understand and have a history of the data that you're working with, so that you can be a little proactive and implement your own partitioning strategy to get around that. If you don't need to key your data, if you don't need that ordering of your data within the partitions, then the way to get around it is to not use a key, right? And so the default partitioning strategy in Kafka uses a sticky partitioner. And so if there's no key for the data, if you don't pass one in, then it's already going to balance the data for you, okay? So that partitioning strategy is going to do a really, really good job at maintaining even distribution across those partitions. But that's only if you don't care about having data with the same key on the same partition. So trade-offs. Yeah. I think we have time for one more. We have one over. He had his hand up.
So I have a question about compact topics.
Yes.
It says that if we provide the same key, then the oldest record will be updated by the
Yes.
new record. But when we look into the consumer side, it's not like that actually. So if we start saying that we wanted to read the records or messages at the consumer end from beginning, we still see the duplicate records. So
Yeah.
it's some flaw with the Kafka or how we tested
Is
it.
something wrong with Kafka? No, it's a feature. So to summarize what he asked, so this is kind of like an intermediate subject or a terminology. So we have the idea of a compact topic. So remember when I said that topics are immutable? That's not completely true. So hand waving. So when you configure a topic to be compact, we have a compaction mechanism that's going to go through at some magically black box time. We don't know when it's going to happen, or it's complicated. It's going to go through and it's going to look at, for old messages for a given key, it's going to erase them, right? So if you just want, if you want like a lookup table and that's slowly changing over time and you're writing that to a Kafka topic for use in your Kafka Streams application, you really only want the latest value in that topic, right, to maintain that for joining. And so yeah, a compact topic is going to do that. But like I said, when the compaction process actually runs and cleans up that data, it's anybody's guess when that's going to occur. So in your use case, when you're trying to build up that particular lookup table to know where you're reading from, you have to read through everything in there and maintain a mapping yourself and update it. So if you're doing that processing in Kafka Streams and using something called a K-table, it's going to effectively do that for you and maintain that lookup table within your stream processing application. But to answer your question, is Kafka broken? No, it is not broken. It's just that your compaction isn't necessarily running when you expect it to. Yeah, so for the K-table on Kafka Streams, you can alter the startup time or how long it's going to wait to propagate that K-table before you actually start your processing. So I'd look into that, delaying that just a couple seconds so that it can read the full history of those and update that mapping to the end. Yeah, cool. Yeah, I know we're out of time. If anybody has Kafka questions or just wants to talk about Lego, I'm here all week. And yeah, thanks for coming.